So in this video, we're going to be looking at the ambiguous case of the sine rule. So here I've written that generally an ambiguous case of the sine rule refers to a scenario or a question where there are two distinct triangles given to you. So this will usually mean that one triangle exists within the other. So you can see here that I've got triangle CAB, and so that particular line there demonstrates that there is another triangle, which is B-AB, which exists within the bigger triangle CAB. So if we take a look at this question here, I've said to calculate the height of a building, Kevin here has measured the angle of elevation to the top as 52 degrees. He then walks 20 meters closer to the building and measures the angle of elevation as 60 degrees. And then we're asked to calculate how high the building is. So for the purposes of this question, the way I've interpreted is that it is a right angle triangle. So let's start by drawing the first one. So we can see here that we've got the angle of elevation, so that's him looking up, is 52 degrees. And then we're told, actually I might make this a little bit bigger. So he then walks 20 meters closer to the building. So let's say that that's 20 meters closer. And what's going to happen now is I'm actually going to try and draw a line from there to that. And let's just say that that there is 20 meters. So he's now moved in closer. So that angle, so the angle of elevation from there is 60 degrees. We're then asked to find out how high the building is. So if we look here, so that's H. And that's pretty much all we know. So let's start by looking at the first triangle. I'm going to start actually by labeling my triangle. So I'm going to go A, C, and D. I'm going to call this D dash. So if we look at triangle ACD dash, that's probably the triangle where we have the most amount of information. So just in an effort to try and draw this as correct as possible. We can see here that that's 52 degrees. We obviously know that that angle is an obtuse angle. It's definitely not 90. And we know this length here is 20. So that's length D dash, that's A, and that's C. And that's pretty much all we know. What we can do is, remembering that essentially what we want to try and get to solve is H. So what we can do is actually try and find the length C D dash. So we're going to try and solve for that length there. So what I would do is say that that's length A. You know, if that degree is 60 there, that means that that's going to be 120 degrees. We know that a triangle, all the angles in a triangle need to add up to 180, which then means that angle C is going to be 8 degrees. So using all this information now, let's use the sine rule. So we've got A divided by sine of 52 degrees is equal to 20 divided by sine of 8. So now rearranging this equation to let A equal itself, so I'm just going to quickly go through the working out. So we're going to get A is equal to 113.242 meters. So I'm going to keep it to 3 decimal places just because it's going to obviously minimize our rounding errors. So now that we know that this length here is 113.242, we can look at all the other information that we have. So we've got a reference angle there, and obviously we know that we're trying to find H. So what we can do is use our trigonometry ratio. So given that we have our hypotenuse, our opposite side is actually H. So I'm going to redraw another right angle triangle this time. See? So obviously we are trying to solve for H, which is our opposite. Our hypotenuse is 113.242 meters. So we can obviously use our sine rule again here. So we know that this angle is 60 degrees. So I'm going to say sine of 60 degrees is equal to our opposite, so that's h, divided by 113.242. Solving for h, I'm going to get h is equal to 98.07 meters.